So yeah, I'm Commander Wayne Bays from HSL 45, and this is the SH-60 Bravo Seahawk, and it's primarily a version, it's a Navy version of the Army Black Hawk that's been redesigned for work at sea in support of carrier strike groups. And primary missions we usually worry about at sea is anti-submarine warfare and anti-surface warfare. So things we have for hunting submarines is we've got things like this device, which is basically a metal detector, and if we fly over metal objects in the water, we can get signals that tell us there's something under the water. So that's one way we can hunt submarines. Another way we hunt submarines is using acoustic listening devices called hydrophones that we shoot out of the aircraft on the left side of the aircraft, and they send signals up to us, and we can tell the sound qualities of the submarines, try and find their position. If we had to, we could drop torpedoes on them to attack submarines as well. The front of the aircraft, you can see this device here is just another antenna. We have 4 of these. This one in particular is used to detect electronic emissions from other radars, either off aircraft or ships. There's 4 of those. This is a weapons pylon, so we could hang a torpedo on this for anti-submarine warfare. The cabin area typically will have one air crewman that sits in the back, but if we're doing search and rescue, we'll also put a second guy in the back so that he can help hoist survivors in and out of the water. In the cockpit, just like with other helicopters, the right and left side have similar controls. The big difference, though, is that the left seat, also has tactical systems where he can fire weapon systems and manage the tactical problem. And that's that little computer screen you see there. But otherwise, the right and left side, control-wise, is identical.
Yeah, you carry a life raft for every single one of us.
And then on the front of the aircraft, you see these are more of these ESM antennas like on the back. Then you have this Flir Pod. So the Flir Pod, forward-looking infrared, is used just like you see in the police movies where you can see the heat of objects. So basically it turns day to night. You can see objects based on their heat reflectivity. Also, this device has a laser designator on it, and the laser is used with some of our targeting systems for instance, the Hellfire missile system. And these objects down here are used to detect missiles being shot at us. So if a missile gets shot at us, the heat source kicks off emergency warning things that tell us we're being shot at. On the other side of your aircraft,
push it and fluid comes out. That means the bladder's closed.
This is another bomb rack.
What they did yesterday too.
So more torpedoes could be hung here. If we had Hellfires on board, we'd extend this thing out a little bit, and you'd hang Hellfire missiles off the left side.
I've worked at United for 12 years.
And that's pretty much it. One thing that's really different on this aircraft from some of the other Blackhawks you see, this whole tail section of the aircraft is much beefier. The tail wheel is much further forward than you'd see on a Blackhawk. And the reason is this aircraft was designed for high impact landings on a rolling ship deck like on a cruiser. So the entire tail section had to be strengthened and hardened to survive shipboard landings. So if you look at a Blackhawk, like an Army Blackhawk, you'll see it's much thinner in the back and the tail wheel's further aft.
So this is
folding. And this device is kind of unique for helicopters. The Sikorsky Blackhawk is has a center of gravity that's very aft, and so to compensate for that, this thing automatically programs up and down while we go in different speeds of flight to ensure that the nose of the aircraft stays basically level. So this helicopter actually flies more like a plane, and that the nose pretty much stays level at different speeds. Whereas in other helicopters with a fixed stabilator tend to, when they go faster, they have to fly like this or like this. Our aircraft basically stays true to the horizon. And there's the tail rotor. It's actually a lot bigger than it looks from here. It's 11 feet across. And when that thing's spinning, it's spinning at about 1100 RPM.
Is this folding?
Yep. One thing, because our aircraft is designed to cruise on ships, it has to be stowed in hangars. So the entire rotor head assembly and the tail section fold in on itself. So our rotor head, we can automatically, all the blades will disconnect and fold backwards. And this section here lifts up, and the entire tail pylon folds back against itself. And when it's all folded up, the actual length of the helicopter is about half what it is now, and the width is much thinner because you get the blades back towards the fuselage. Some of these things are communications. So this one is just a metal detector that helps us tell where north, south, east, west is, like a magnetic compass. This is a communication system that basically provides a digital communication with the ship that we operate with. And then these are just like any other aircraft, UHF, VHF radio antennas.
What about the gasoline?
We have, this helicopter is powered by jet engines. This one is a smaller engine, which is an auxiliary engine that we start up in order to start the main engines. And then the main engines are both General Electric T700 401 Charlies, and they each put out about 1900 horsepower of energy that drives the transmission that turns the rotor head. The aircraft's designed to where it can fly. If one of the engines fails, it can fly on one engine. Not as well, it doesn't have as much power, but it's designed so that you could lose one engine and still fly.
Can you talk a little bit about corrosion?
Sure, corrosion. You'll notice it's not spotless. It's not totally clean. These aircraft are exposed to salt water all the time when we're operating at sea, and so it's a constant maintenance effort to keep the aircraft from rusting, to keep corrosion from impinging on some of these surfaces. You see on these dissimilar metals like this, in particular, at sea, if you get salt water on this, it rusts over on almost a daily basis. So we're constantly putting preservatives on these aircraft. We're constantly washing them. Whereas our Army brethren that are flying over land, they're not exposed to those same corrosive elements, obviously.
Excellent.
Yeah.
How you fold the rotor?
It's electromechanical. You see these little pistons, these worm screws that come out this way? When we flip a switch, those two little pulleys drive worm screws out this way, which unhinge the blade. And then the blades fold back one at a time. There's an automatic system that aligns the rotor head in the right position so all the blades fold back together.
I'm going to go by deep down to hear the radio that